Hello there. Welcome back to IT grade 11. In this video, I want to look at a match test, and we are going to look at question 3 of this question paper, that is on hardware, and we are going to look at computer architecture in particular. So we have got a question that we want to go through. So we have got information that we are given before the questions. So the information is your school wants to upgrade their computers. They have decided to purchase some new ones as well as refurbish some of the old ones. One of the teachers approached you to assist them in making the right decision when it comes to purchasing computers and upgrading the old one. Assist them in defining technical terms related to modern PC designs. So on the first part of our question, that is 3.1, to give a brief account of the purpose of a chipset in a computer. Our question has got 2 marks. So you would see that a chipset in a computer is a set of electronic components on one or more integrated circuits that manages the data flow between the processor, the memory, and the peripherals. So you will see that at the end of the day, the chipset is usually found on the motherboard of computers, and chipsets are usually designed to work with a specific family of microprocessors. So you see that this is the basic explanation that we have in terms of chipsets in computers. But if you go back to our question, you see that it requires us to come up with the purpose of a chipset in computers. So we have that articulated in our answer section. So if you come to answer section, you see that what the first part is a brief explanation in terms of the chipset, whereby say it is a set of chips that is integrated circuits used on the motherboard to connect components. So in terms of the purpose, it controls and handles connections of respective circuits and pass to the motherboard. So basically, that's what we have in response to our question 3.1. So we go to the next part of our question, which is 3.2, which reads, examine the diagram below and indicate possible components labeled for A, B, C, and D, respectively. So you go to our diagram, you see that we've got A, and you see that our A is representing the RAM. So we have the RAM being represented by A, and then you go to B, you see that B is being represented by the PCI Express. Then you see that the PCI Express, it is a serial expansion bus standard for, so you see that it is a serial expansion bus standard for connecting a computer to one or more peripheral devices. So basically, that's what we have in terms of our B, which is indicating our PCI Express. Then we go to C. C is standing for the PCI, which is the peripheral components interconnect, and it is a local computer bus for attaching hardware devices in computer. So basically, that's the brief description that we can have in terms of PCI. Then lastly, we've got our D, which is standing for the USB. So D becomes the USB, which is part. So we've got the South Bridge on this side, and also we've got the North Bridge. North Bridge are being attached to A and B, and South Bridge being attached to our C and D. So on the next question, which is 3.3, please highlight the difference between the I/O bus and the expansion bus by stating the main function of each. So basically, you would see that in terms of the I/O bus, we are going to look at the FSB in particular, the FSB being the front side bus. So you see that the FSB becomes an example of the I/O bus. So it is a pathway to transfer data between the CPU and RAM, and it also connects the CPU and the rest of the hardware via the North Bridge. Then also we have the expansion bus, whereby you're saying the expansion bus allows you to connect other components to your computer. So basically, those are the typical descriptions that we're going to give in terms of the I/O bus, and also the expansion bus. So we have that also stated in our answer section, as we are saying. Uh, we are now on 3.3. We are starting with the FSB, as we are saying. The FSB is an example of the I/O bus. So the FSB is a pathway to transfer data between the CPU and the rest of the hardware via the North Bridge. And then the expansion bus allows to connect other components to your computer. So basically, those are the explanations. So if you go to our questions, the question requires us uh, to state the main function of each, of which we have just stated in terms of the I/O bus and expansion bus. So we go to 3.4, it is state two problems that may arise as a result of overclocking a CPU. State two problems that may arise as a result of overclocking a CPU. So you see that it's at the end of the day, if there is overclocking, it means the CPU perform beyond the stock performance, therefore putting a strain on the CPU. So that's so the issue of putting a strain on the CPU becomes a problem. And also you're going to see that at the end of the day, there will be now, due to the issue of overstrain, we're going to have overheating occurring. So that will lead to the malfunctioning of the device. So those are some of the problems that we are just going to state on the answer section. So we have them again as stated on the answer section, whereby we have uh, 3.4, it will perform beyond the stock performance, thus putting a strain on the CPU. And we are seeing overheating occurring. It's a problem. The device may malfunction again. That is the problems that we are just trying to highlight there. Then I will go to the next part of our question, which is now saying, the new computers contain two USB ports and a FireWire port and a HDMI port. 3.5.1 suggests one use of a FireWire port. So now the 3.5.1, we need to suggest the use of a FireWire port. So you'd see that it connects digital video cameras or multimedia devices. So that's what we have on 3.5.1. So we go to our other section and try to see 3.5.1 connects digital video cameras or multimedia devices. So we have them stated there. Then we go to the next part of our question. What does HDMI stand for? And we know that HDMI stands for high definition multimedia interface. So that's what we have. And then one advantage of this type of port is that no risk of quality, there's no risk of quality loss. So that's what we have. Another advantage that we can try to bring in is that it is an all digital interface that does not require conversion at either end. So if you go to answer section, we have also that stated as it reads no risk of quality loss is the one that is only stated, but we have also came up with another that is saying it is an all digital interface that does not require conversion at either end. So basically that's what we have in terms of 3.5.2. Then we go to the next one, 3.6. Explain how Blu-ray discs store read and write information as opposed to normal DVDs. So our question is for 2 marks. That is our 3.6. So going to our 3.6, we are saying they store large volumes of high definition video and audio. That is uses blue laser instead of red shorter wavelength. So you see that it can hold 5 times more data than a DVD. So basically, that's how we can try to come up with our 3.6. So on 3.6 again, we are saying they store large volumes of high definition video and audio, uses a blue laser instead of red shorter wavelength, can hold 5 times more data than a DVD. So those are the points that we have on 3.6. Then we go to the next one, to 3.7. How are SSDs different from magnetic hard drives? State 3 advantages that SSDs have over SATA and IDE drives. Question has got 4 marks. So we are saying on the first part, our SSDs different from magnetic hard drives. So you see that SSDs, they have no moving parts. They do not rely on magnetic fields. They use electric current. They are much faster. They have no noise, no physical damage due to impacts. So those are the points that are supporting how SSDs are different from magnetic hard drives. Then in terms of advantages that SSDs have over SATA and IDE drives, we are saying less susceptible to physical shock. They have a lower access time or latence. And also they do not need to be different since they have no moving parts. So those points again are stated on our session. So we are saying 3.7. You go to 3.7, we are saying that on the first part, they have no moving parts. They do not rely on magnetic fields. That is, they use electric current much faster, and no noise and no physical damage due to impacts. So in terms of the advantages, we are saying are less susceptible to physical shock. They have lower access time or latence. They do not need to be defend since they have no moving parts. So that's what we have on 3.7. Then we go to 3.8. 3.8 reads, what are the components of access time on a disk? What are the components of access time on a disk? So you'd see that we have got seek time and also latence time. Seek time and latence time. So we try to see what we have in terms of that. We have got seek time plus latence time. So basically that's what we have. Then we go to the next part, which is now 3.9. Cache memory is an integral part of the modern computer system. The earliest form of cache in the CPU has led to other ways, disk caching, browser caching, and web caching. Then on 3.9a, describe the levels of cache in the computer in and around the CPU by giving their locations. Remarks, discuss the two types of caching underlined in the statement above. So this is what we have. So we're going to start with A. You say describe the levels of cache in the computer in and around the CPU by giving their location. So we are going to start with L1, which is the small amount built in the internal circuitry of the CPU chip, and then we've got L2, it's larger than L1. It's larger than L1. It's on the CPU chip, slightly further from internal circuitry, but slower than L1. Then we've got L3. It's on the actual board itself, but very closer to CPU than RAM, larger and slower than both L1 and L2. So those are the levels of cache that we have. So we have also those are stated answer section where we have L1, L2, and also we have got L3. So the explanations also are there in terms of L1, L2, and L3. Then in terms of the next question that we have, we now go to B is saying discuss the other two types of caching underlined in the statement above, which is disk caching, browser caching, and web caching. And the question only needs two. So we can start with the disk caching, whereby we are saying disk caching. It has a fast access area of the hard disk. So that's the explanation that we have in terms of disk caching, whereby we're saying fast access area of the hard disk or RAM are set aside for recently used files in the hope that they will be used again. That's the disk caching. Then in terms of web caching, we are saying it is shared. Web caching is shared store of previously downloaded web pages. So that's web caching. So that's what we have. And if you look at our question is saying discuss the two other types. So within this context, we have tried to discuss in terms of disk caching and also web caching, whereby web caching, we are saying it is a shared store of previously downloaded web pages. And disk caching, we are saying fast access area of the hard disk or RAM set aside for recently used files in the hope that they will be used again. So basically, that's marks at the end of our question 3. That is on the March test question paper. So thank you for listening. So please, let's meet again in the next video. Let's not forget that more typical examination questions are going to be uploaded on this channel. So let's not forget to subscribe and share. As for this video, I'm out.